It was Thomas Edison, scientist and inventor, who said, "I'd put my money on the sun and solar energy. What a source of power." I hope we don't have to wait till oil and coal run out before we tackle that. In this lesson, we're going to compute the cost of electricity, gas, oil, and water for the home. We will compute the cost of using specific appliances for specific lengths of time, and we will compute the time it takes an energy-saving appliance to pay for itself. All to answer the question, how much will it cost to run the utilities in your home? Before we get into it, let's make sure we're ready for this lesson by taking a look at warm-up number 2, where Tammy draws a circular plot and regression line plotting her hours worked, X, and tips, Y, which represents the unit of the slope. We understand that slope itself is the change in Y over the change in X. In this case, Y is tips or dollars, and hours worked is X. So we need hours in the denominator. It can't be A because it's only dollars. When it comes to B or C, only C has dollars in the numerator and hours in the denominator. Now let's take a look at a question that you will be able to answer by the end of this lesson. Michael purchased a desktop computer with a monitor for $2,500. Michael always leaves both in the power up mode. On average, his make and model costs a total of $96 per year to run in electricity costs when it is constantly on. What is the average yearly cost to own and operate this computer system at the end of 5 years? Michael's average yearly cost can be modeled by a cost function, which is a combination of the initial purchase price and the accumulating yearly electric expenses. So the cost of the computer, C of X, is equal to the actual dollars of the computer, $2,500, plus the yearly cost of $96 a year times X. Michael now wants to set up an average cost rational function. A of X, which is the quotient of the accumulated yearly costs and the number of years owned and operated. So A of X is equal to C of X divided by X equal to 2,500 plus 96X divided by X. We know that X represents the number of years and X is 5. So we can substitute the value 5 into the equation, giving us A of X is equal to 2,500 plus 96 times 5, all divided by 5. This gives us $596. So after 5 years, Michael's average annual cost of owning and operating the computer that is currently on will be $596 a year. If you own a home, and often when you rent an apartment, you are charged for using electricity, natural gas, and/or heating oil and water. These services are utilities. You pay for utilities after you use them, so you are actually using credit when you purchase utilities. Many people don't think about the cost of these services as they're using them. How much electricity do you use? You probably don't know the exact amount, but it is recorded on a meter. An employee of the electric company comes to your home to read the meter to determine how much electricity you used. Every electronic appliance uses electricity. Electricity is measured in watts. The amount of electricity used is measured in watt hours. For example, a 60-watt light bulb burning for 2 hours uses 120 watt hours. A kilowatt hour is equivalent to 1,000 watt hours of electrical use. Electricity is sold by the kilowatt hour. Water and gas are sold by the cubic foot, which represents the amount of space the gas or water occupies, not the weight. The amount of space is the volume. The unit, CCF, represents 100 cubic feet. You can think of 1 cubic foot as the space occupied by a box that measures 1 foot on each edge. The water usage could also be measured in gallons, which are also a unit of volume. Think of a large milk container to understand a gallon. Your home has a water meter that displays the number of gallons or the number of CCF, depending on how the usage is calibrated. Most communities use water meters to monitor your water consumption. Natural gas usage is also checked by someone reading a meter at your home. Natural gas meters display gas usage in CCF also. When you are billing your natural gas usage, the units are often reported in therms, which is a measure of energy. A therm is approximately equivalent to 1 CCF. Here you're going to learn how your natural gas, water, and electricity is measured and how to read the meters and utility bill. Electric and gas meters have dials that display usage. The units for natural gas are 100 cubic feet CCF, and the units for electricity are kilowatt hours kWh. A previous reading in the last time of the meter was read. A present reading is the current meter reading. Now let's compute the cost of electric, gas, oil, and/or water for the home. Tom's October water bill listed 2 meter readings. The previous reading was 3,128 CCF, and the present reading is 3,141 CCF. How much water did Tom's household use during the billing period? To do this, we're going to subtract the number of CCF of water used. So 3141 minus 3128 is going to give us 13. Tom's household used 13 CCF of water during the billing period. Let's check our understanding of this when Ron used X CCF of water during the summer month and express the number as cubic feet of water he used algebraically. We need to remember that the unit of measure is 100 CCF. So at 100 times X, the CCFs being 100, and that is all that it takes to write it algebraically. Now, Janet works for a utility company and is reading the Saevitzs household electricity meter. What is the reading? Some meters are digital, and some meters use number circular dials with pointers like those that we see here. Digital meters are easy to read. Take a look at the dial style meters below. Notice where the arrow is pointing to each dial. The correct reading is the lower of the 2 numbers closest to the arrow, with one exception. If the arrow points between 0 and 9, the read is as 9. We can see that this first one reads as 0, the second one reads as a 9, then we get a 5, and a 1. The meter shows 9,551 kilowatt hours of electricity. Some utility companies are installing digital meters which can be read more easily. Let's check your understanding by saying, what is the CCF reading indicated by the dials? Well, here we see the smaller number is 3. Again, the smaller number is 3. The smaller number is 5, and when between 0 and 9, it is 9. So we have 3,359 kilowatt hours. Now let's compute the cost of using a specific appliance for a specific length of time. A certain electronic mixer requires 125 watts. How much would it cost to run the mixer for a total of 90 minutes at a cost of 10 cents per kilowatt hour? To calculate the operating cost of an electronic appliance by checking its wattage and the time used. So 90 minutes would be equal to 90 minutes per 60-minute hour, which is equal to 1.5 hours. The number of watt hours is the product of watts and the number of hours the appliance uses, meaning 125 times the 1.5 we just figured out is going to give us 187.5 watt hours. Electric usage is billed by the kilowatt hour, which is 1,000 watt hours. To express the 187.5 watt hours as kilowatt hours, we simply divide by 1,000, giving us 0.1875 kilowatt hours. If a kilowatt hour costs 10 cents, multiply the kilowatt hours by 10 cents to find the cost of using the mixer for 90 minutes. So when we multiply by 0.1, we get 0.0187.5. The mixer cost approximately 2 cents to run for 90 minutes, or 1.9 cents. This is between 1 and 2 cents, obviously. Let's check your understanding of this by looking at an appliance which uses W watts. If you run it for M minutes and the cost per kilowatt hour is C, express the cost of running an appliance for M minutes algebraically. So the watts times the minutes, and we add 60. Now we're looking at all this together, which means put it in parentheses. We can divide it by the 1,000, which is the kilowatt hours, and multiply it by the cost, which is C, giving us the algebraic expression. Now, depending on the climate, utility usage can vary according to the seasons. Electric bills can be higher in the summer due to air conditioning use, and gas and oil usage can be higher in the winter due to heating needs. For this reason, some utility companies offer balanced billing. This evens out the monthly cost of utilities to make the homeowner's payments predictable. Last year, the Ross family spent $3,336 for electricity. They are opting to use the balanced billing for the next year. What will their monthly payment be? Balance billing uses the previous year to determine monthly payments for the upcoming year. So if they spent $3,336 for the year, if we divide that by 12, we get a $278 bill. So the Ross monthly electric bill will be $278 under the balance billing program. Let's check our understanding of this by looking at 2 years ago. The Halloran family used Y dollars of electricity. Last year, they used balance billing. During the last year, they used X dollars of electricity, and their balance billing payments were not enough to pay for the electric usage. They had to pay the difference at the end of the year. Express algebraically the amount they owed to the utility company. They used X dollars last year. If we subtract from that 2 years ago, we're going to wind up with a negative dollar amount. That is what they would see. That dollar amount is how much they would have to send to the electricity company, so simply X minus Y is the algebraic expression. Now, let's compute the time it takes an energy-saving appliance to pay for itself. Energy-saving appliances often pay for themselves. This means that the savings in energy usage can equal or offset the cost of the item after a certain number of years. The Thomsons old water heater cost them $455 per year to run. The new one they purchased for $1,240 will save them 31% annually in energy costs to run it. In how many years will it pay for itself? First, we need to compute the average savings per year by finding 31% of 455. So 455 times 0.31 will give us $141 and 5 years. So 455 times 0.31 will give us 141.05. Now we need to divide the cost of the new appliance by the annual savings of energy. So $1,240, the cost of the appliance, divided by their annual savings, $141.05, will give approximately 8.791. So the water heater will pay for itself in about 9 years, since it will take more than 8 years to save more than the $1,240 they spent on it. Let's check our understanding. An old dishwasher costs R dollars to run for a year. It is replaced with a new energy-efficient dishwasher that costs C dollars, but saves P% per year in energy usage. Express algebraically the number of years it will take for the dishwasher to pay for itself. So the first thing that we're going to do is the cost to run the dishwasher, R, times the percent that we're going to save, P. Remember that P tends to say something like 3.1, so we want to divide that by 100. All of this will be dividing the cost of the dishwasher itself. So this whole thing becomes our expression. Let's take a look at some rational functions. Now, we've studied utility expenses. You will now examine the average electric utility costs of running appliances in a home using an average cost function in the form of a rational function. A function is a rule that assigns a unique member of the range for each element of the domain. So, for example, we can look at the limit of a polynomial function. A rational function is an algebraic fraction in which both the numerator and denominator are polynomials. So an example of a polynomial function would be a of x can be equal to 2 divided by x minus 3. Another example of a polynomial function can be b of x being equal to 2x plus 5 divided by x. Or another being c of x is 2x squared minus 5x minus 3 divided by x minus 4. In general, a rational function has the form f of x is equal to g of x divided by h of x, where g of x and h of x are polynomials and h of x, the denominator, cannot be equal to 0. Notice the value of x where the polynomial in the denominator equals 0 must be excluded since dividing by 0 is undefined. A rational function in the next example will give you information about yearly average cost of running an electric device in a home. So Michael purchased a desktop computer with a monitor for $2,500. Michael always leaves both in the power up mode. On average, his make and model costs a total of $96 per year to run in electricity costs when it is constantly on. What is the average yearly cost to own and operate this computer system at the end of 5 years? Michael's average yearly cost can be modeled by a cost function, which is a combination of the initial purchase price and the accumulating yearly electric expenses. So we're going to let C of X be the initial cost of the computer, $2,500, plus the yearly cost to run it, $96 per year, which in this case is X. Michael now wants to set up an average cost rational function, A of X, which is a quotient of the accumulating yearly costs and the number of years owned and operated. This means that A of X is equal to C of X divided by X, or simply 2,500 plus 96x divided by X. Now we already know that X is 5, so we can substitute this into the equation, giving us 2,500 plus 96 times 5 divided by 5 to get 596. After 5 years, Michael's average annual cost of owning and operating a computer that is constantly on will be $596. Let's check our understanding of this by looking at Sita purchased a hot water heater for her home for $580. It cost her $120 to have it installed. The energy information card that came with the purchase indicates that this make and model of hot water heater will use approximately $620 per year in electricity. Set up an average cost rational function for this purchase. Identify the variable. What is the average yearly cost after 8 years of usage? Well, we can see that the hot water heater cost $580 plus $120 to install, meaning the heater actually cost $700. So the cost of the water heater, C of X, is equal to 700 plus the yearly cost, $620 per year, or X. A of X is C of X divided by X, giving us 700 plus 620x divided by X. If we substitute in the number of years, because here we know that X is 8, this means that 700 plus 620 times 8, all divided by 8, will give us $707.50. The average yearly cost after 8 years of usage will be $707.50.